Okay, let's try another example. In this example, I want to talk to you about changing the order of integration. And so I picked an integral with a very, very simple function so that we can focus on the region of integration. So this is my function, constant function 1, and this is my region of integration. It's always good to draw your region of integration. So let's translate this into inequalities. So in inequalities, that region of integration is y goes between 0 and 2, and x goes between y squared and 4. So it's best to draw it as think of these as lines and these as domain. Okay, so if I draw, let's see, x equals 1, 2, 3, 4, 1, 2, 1, 2. And let's draw in red, how about? So then x equals 4 is a line. Think of it as a line. And then x equals y squared is the parabola that goes to the right instead of up and down. So there and there. And I guess you could keep going, but you don't have to. Okay. And so then the domain is basically like y goes from 0 to 2. So as y goes from 0 to 2, the x's go between the two red lines. And so we stop when we get to y equals 2, which means like that's our region of integration. So I don't even need the bottom here. So I'm gonna redraw a little bit so I can have space to draw it a second time. Okay. Redraw there. All right, let's draw it again. 1, 2, 3, 4. 1, 2. Let's draw it again. This time we want to switch the order of integration. So looking at that picture, so with the same picture, the same lines. So 1, 1, 2, 4. So instead of doing horizontal lines, in order to switch integration, you have to do vertical lines. And so what are the lines, blue lines going in between here? They're going in between y equals 0, and this would be y equals square root of x, because it's the upper half of x equals y squared. So, and then what is the domain? What x's are we going? X is going from 0 to 4. So we could draw, so this region is the same as 0 less than equal to x less than equal to 4, y between 0 less than equal to y less than equal to square root of x. Okay, these are the same region. Same. Which means that if I swap integration, so 0 to 2, y squared to 4 of my function is just 1, dx dy, if I swap integration, then the outside becomes 0 to 4, and the inside becomes 0 to square root of x. And the function just stays the same, dx dy. Okay, so the main idea of this is just to show you that changing the order of integration is not something you should do willy-nilly. You should draw the picture. You should think of these bounds on your integrals as the inner one as lines, the outer one as domain, and that will help you correctly change the order of integration. So that completes this example.